Welcome to Mat 1260, Intro to Statistics. This will be a brief introduction to the vocabulary we'll be using in the course this semester. Typically, these notes are a page at a time. I try to keep the recordings between 5 and 10 minutes. This one will be all 3 pages in a single recording. It should not take us too long. It's important, before you listen to the recordings, to go through and read what's in the notes, maybe check with the answer key, see what you know and don't, and then hone in on the part of the notes that you really need to pay attention to. So at the top here, we have an intro to statistics. We're going to take a look at this using a 4-step process. Step 1 is producing the data. Step 2 really is our Unit 1, that exploratory data analysis, how we look at the data we've collected. Step 3 is our Unit 2. We'll talk about calculating probabilities. Step 4, inferring. Our significance tests, our hypothesis tests, and making inferences about a population based on a sample. Again, I am not going to read all of these to you. You can pause now if you would like. We are going to focus on a chunk of these terms here right now. We are going to start by talking about a population and what's called a parameter. So our parameters are going to be those values that describe the population. It could be an average of the population. It could be a proportion. Anytime you see that word parameter, you know that we are talking about the population. We are also going to talk about a sample, which is a subset of the population that is being studied. It's got to come from our actual population to be worthwhile for us. Whenever we're talking about those numerical values that are describing our sample, we're going to refer to those as statistics. And we're going to get a little more involved in those later on. Okay. These are the terms we are going to focus on now as we take a look at example 1. Okay. If we are talking about the students on our campus, then when we say suppose 48.2% of all students on the campus own a car, that 48.2% is a parameter. It's referring to the population that we're interested in, which is the students on our campus. Okay? If we dive down a little deeper and we sample 100 students, then we have a statistic. And here our statistic is this 46% that own a car. So we are going to use samples and statistics to compare to our population parameters. Okay. I am not going to read part B to you. Again, feel free to reach out if you have questions on any of that. Just wanted a brief overview of the difference between a population and its parameter and a sample and its statistic. Okay. We are going to move on to page 2. We're going to talk about types of variables. We have got qualitative, sometimes we call them categorical variables. Think quality when we talk about qualitative. So they're descriptors or things that can be clustered into categories or groups. Okay. So we're talking here eye color, grade in high school, things that don't have numerical values that go with them. We also have quantitative variables. Think quantity, number. Okay. And these are going to be our numerical values. When we talk about quantitative variables, we do have two different types. We have discrete variables. Discrete variables are our countable values. Okay? So if you take a look at the graph here, we are looking at number of children and number of students. So we're starting with number of children, and we're taking a look at how many students have that many children. If we are counting children, we've got whole number values, 0, 1, 2, 3, 4. Notice even if it's not marked in here, we know that halfway between 0 and 2 are the number of students that have one child. This point right here means that 20 students have one child. Notice these are random separated dots. There is no way to get from one child to two children continuously, because there are not going to be any students that have 2.5 children. Okay, now, when we talk about discrete variables, we talk about them being countable. They don't always have to be whole numbers. Think about shoe sizes. I can have a size 4, a size 4.5, a size 5, and so on. Oops, 5.5. There is no way to have a size 5.3 shoe. Okay? So although these are not whole numbers, they're still countable and separate. This is different than our other type of numerical variable. We have continuous variables. These can take infinitely many values, and the best way to think about this is to get, here we're talking about average monthly temperatures. If I want to get from 42 to 44 degrees, I have to pass through everything between them. Even if I don't mark it, I have to hit 42.1 degrees at some point to move on to 42.15 and 42.2. Okay. So discrete variables, separate and distinct, continuous variables, we can travel through a range, and actually we have to travel through a range to get from one value to another. Our final page here, page 3, example 4. This would be a great time to pause the recording and take a look at example 4. Decide whether you think these values are discrete or continuous. So let's take a look at situation A. A says we're counting the number of heads obtained after flipping a coin 5 times, and I gave it away when I said we are counting. This is definitely discrete. Okay? I am going to have 0, 1, 2, 3, 4, or 5 heads. There is no way to get 3.3 heads or 1.5 heads. I'm skipping. Definitely discrete. B, the number of cars that arrive at a McDonald's drive-thru between 12 p.m. and 1 p.m. Again, that is going to be discrete. Even if it doesn't look like it, everybody coming through is a whole car. There's no way to get half a car. So we're going to write that here, no half cars. See, the distance a 2020 Toyota Prius can travel in a city driving conditions with a full tank of gas. This one's going to be continuous. This Prius could travel 480 miles on a tank of gas, 481.2 miles. There is no way to tell exactly how many miles this is going to have. And when we get in that 480 to 500 range, it really could take on any value, depending on the driving conditions. And I'm going to put almost any value because we know we're not driving 2,000 miles. So these are values within reason. Okay. Last thing we want to point out is something called a designator. Now, this is a numerical value, but it's more of a placeholder than anything else. So think jersey numbers. If we are taking a look at a soccer team, everybody's got a jersey number. It doesn't do me any good to find an average of that number. There is no use for an average jersey number. Okay. Same thing with phone numbers, license plate numbers. They identify an individual in the set, but it is not something numerically that can be used to describe the set. So we're going to make that note here. Cannot be used to describe the set. And that's it for the first set of notes.